The first topic I thought would be most likely to be on the AP exam is integration by parts with the product rule. The original product rule is d over dx of f of x times g of x equals f prime of x times g of x plus g prime of x times f of x. To use that for integration, you have to change it to the integral of u times v prime dx equals u times v minus the integral of v times u prime dx. Some definitions for this topic include integrand, which is the expression being integrated, integration by parts, which is a method for integrating a product of two functions. Limits of integration are domain values that bound the integral, and product rule is the method for differentiating the product of two or more functions. A reminder for this topic is to be sure that when you use integration by parts for the product rule, you make u equal something that the derivative can be taken of, and you make v equal something that the integral can be taken of. This is because when you're splitting the integral into a function and another integral, you need to be able to get u prime from u, and you need to be able to get v from v prime. An example for this topic is the integral of x squared times e to the negative x dx. Since this is the multiplication of two functions in the integrand, you can use integration by parts with the product rule if you have u equal x squared and v prime, or dv, which is what I'll be writing, equal to e to the negative x. When you take the derivative of u to get u prime, or du, which is what I write, you get 2x dx, and when you integrate dv, you get v equals negative e to the negative x. Putting this in the form of u times v minus the integral of v times u prime dx will get you x squared times negative e to the negative x minus the integral of negative e to the negative x times 2x dx. When you simplify that, you get negative x squared e to the negative x plus 2 times the integral of x e to the negative x dx. You'll notice that you have two more functions being multiplied under your new integrand, so you need to use integration by parts with the product rule again. This time u can equal x, dv can equal e to the negative x again, du will equal dx, and v will equal negative e to the negative x again. When you put this in the form of u times v minus the integral of v times u prime dx, you have to use the original u times v when you first use integration by parts with the product rule, because you're still subtracting the integral of v times u prime dx from the original one. You just change the way that looks. So when you simplify and plug in all this, you get negative x squared times e to the negative x plus 2 times x times negative e to the negative x minus the integral of negative e to the negative x dx. Simplified, that is negative x squared times e to the negative x minus 2x e to the negative x plus 2 times the integral of e to the negative x dx. Now we have something we can straight up take the integral of under the integrand, and so the answer to the equation, or the problem, is negative x squared times e to the negative x minus 2x e to the negative x minus 2 times e to the negative x plus c. The second topic I thought would be most likely to be on the AP exam from this module is improper integrals. So an integral is improper if it's in the form of the integral from a to b of f of x dx, and either a or b is infinity or negative infinity, or the region defined by f of x has an infinite discontinuity. When a limit of integration is infinity or has a discontinuity, you can plug t in for that value to replace it, and then you can take the limit as t approaches that value of the integral so that you can actually solve it. If the upper limit of integration is a discontinuity, you can replace it with t, and then you approach the limit from the left because that's the side that you're taking the integral of, and vice versa. If the lower limit of the integration is a discontinuity, you replace it with t and approach it from the right. Some definitions for this topic are a convergent improper integral, which is an improper integral that has a defined value as found through taking a limit. Discontinuity is a place where a graph has a break in its domain from a hole, a jump, or a vertical asymptote. A divergent improper integral is an improper integral that does not have a defined value since the limit at the integral's value does not exist. An improper integral is a definite integral with at least one limit of integration that is infinite, or where an infinite limit is contained between the limits of integration. An infinite limit is a limit that approaches a y value of infinity or negative infinity, and limits at infinity are limits of a function as it approaches infinity or negative infinity. A reminder for this topic is to remember to plug in the t value into the limit at the end of the integration process so that you can find out if the integral converges or diverges. If you do not plug in the t value at the end, it's pointless to do anything with the integral because you won't be able to solve it without using t, and then if you don't plug in t again, you're still not able to solve it. An example for this topic is the integral from 1 to infinity of 1 over the 7th root of x to the 4th dx. That simplified is the integral from 1 to infinity of x to the negative 7/4 dx. Since one of our limits of integration is infinity, we can plug in t there and then take the limit of this integral as t approaches that value. So we have the limit as t approaches infinity of the integral of 1 to t of x to the negative 7/4 dx. X to the negative 7/4 can be integrated pretty easily. So now we have the limit as t approaches infinity of x to the negative 3/4 divided by negative 3/4 defined from 1 to t. That simplified is the limit as t approaches infinity of negative 4 times x to the negative 3/4 over 3 defined from 1 to t. When you plug in t and 1 to define this, you get the limit as t approaches infinity of negative 4 times t to the negative 3/4 power divided by 3 minus negative 4 times 1 to the negative 3/4 power divided by 3. That simplified is the limit as t approaches infinity of negative 4 divided by 3 times t to the 3/4 power plus 4/3, because 1 to any power is 1 and the two negatives cancel. And then to get the t on the bottom, you use the negative in the exponent. So now that we have it all simplified, we can plug in t again where the limit value is. So we plug in infinity for t, and you get negative 4 divided by infinity, because anything times infinity to any power is infinity, plus 4/3, and anything divided by infinity is essentially 0. So the final answer is 4/3, which means that this integral converges to 4/3.